Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So for today, I'm going to continue the topic polymer under subtopic 4.2, which is natural rubber. Okay, so what is natural rubber? Natural rubber, or the other name we also call as latex, or normally Malay people akan sebut sebagai susu getah. Okay, and we focus on this latex or natural rubber because it is one of the example of natural polymer. Why is example for natural polymer? Because everyone knows the latex is produced from the rubber tree. So daripada sumber semula jadi, that's why latex is considered as natural polymer. Okay, so let's recall what is polymer. Polymer is a long chain molecule made up from a repeating subunit called monomer. So you already learned about this under topic carbon compound, chapter 2, form 5, carbon compound, talking about polymer. Okay, so polymer is a long chain molecule, meaning that the size is very big size. How it is formed? It is formed when we have the repeating subunit. That repeating subunit have special name, iaitu kita kenali sebagai monomer. So in simple way, we can say polymer is like kereta api yang sangat panjang, made up from repeating gerabak. So the gerabak is the monomer, and the kereta api is the polymer. So to get kereta api, we must have hundreds of gerabak. So the gerabak must join together, and that gerabak also must have similar in shape, design and so on. So kalau diorang tak sama, we cannot combine them. So they are like copy paste each design of the gerabak. So gerabak itulah monomer yang bila bercantum panjang is called as kereta api ataupun polymer. So what is the monomer for natural rubber? Okay, so this is the structural formula for the monomer of natural rubber. Okay, so if we look at on the structure, it contains carbon and hydrogen only, meaning that this compound is hydrocarbon. Okay, and then the functional group is double bond, meaning that it's from alkene. Okay, that's the idea. So how can we give the name for this structure? Actually, dia ada nama dia yang glamour, iaitu isoprene. But it also have the IUPAC name, which is nama yang didaftarkan dengan sistem macam kita let's us our name dekat birth certificate, dekat kita punya surat beranak tu lah. So this compound also have its name or IUPAC name. So let's recall how to give the name, because this is alkene. So the first step, we must identify the longest chain. So this is our longest chain, contain 4 carbon. Okay, 4 carbon. So bila 4 carbon, basic dia adalah dia akan jadi butene. Okay, and we have a side chain 1 carbon, which is methyl or methyl. Okay, so now we must check the position of the double bond. Okay, so what is different this compound dengan the previous alkene yang you dah belajar? This compound have 2 double bond. Okay, so the double bond is at carbon number 1 and carbon number 3, 1 and 3. So let's try to give the name first. It is but. Okay, so put the position of the double bond. Double bond is at carbon number 1, comma 3. We have 2 double bond, boot 1 3, and it is no longer in. Dia akan jadi, dia ada nama di in. Di because we have 2 position of double bond, 1 and 3. Before this, what we learn, we only have 1 position. So kita hanya jumpa boot 1 in. This time, because kita ada 1 and 3, so it will be boot 1 3 die in. That is dia punya longest chain or the main chain. So we have the side chain. Side chain kita adalah 1 carbon. So it is methyl, okay, and our methyl located at carbon number 2. So this is how we get the name for the isoprene IUPAC name. The name is 2-methyl boot 1,3 diene. So ini adalah monomer kita. Okay, this is our monomer. So how can we get the polymer? Okay, from the monomer kita kena bentukkan polymer, but you have to know, like kalau kita nak bentuk kereta api sekalipun, each gerabak to connect between the first and the second gerabak, in between the gerabak you kena make sure you can connect them, meaning that tiada benda yang menghalang the connection between the gerabak. So if you look at to the drawing of the structural formula of monomer, di hujung kiri dan kanan dia tu dia ada H. So ini akan menghalang the connection for the next monomer. So kita akan buat adjustment, reallocate the position of H. So you just copy the structural, the longest chain. So I akan adjust H ke bawah. Why? Untuk memberi ruang kepada the connection di bahagian kiri dan kanan. So the rest I just copy. Okay. Okay. That is the first one. Second, if we look at on the double bond, so kalau kita kira dia dah ada maximum 4 bond. Apa maksudnya? We already have maximum 4 bond. 1 on the left here, 2, 3, 4. So dah cukup 4. So kita tak boleh lagi nak buat connection because carbon maximum 5. So untuk carbon yang di hujung, kita kena make sure dia ada 3 supaya dia boleh buat connection dengan the next monomer. So kalau you look at to the drawing yang for this one is already 3. So how about the double bond? So dia akan ada reallocation of the electron. So dia akan berpindah daripada 2 double bond di hujung, dia akan pindah ke tengah. We only have 1 double bond. Okay, so let's count betul atau tidak kita tidak melebihi bilangan bond. We have 1, 2, 3, 4. And this one, 1, 2, 3, and it can have another 1, 4. Okay, so this is the correct one. So this is the difference between the monomer isoprene and its polymer. Monomer ada 2 double bond, the polymer only have 1 double bond. And when you draw, you have you must make sure you ada letak dia punya bracket, okay, and then put a small letter of N to represent it is repeating. How many N? It doesn't matter. We no need to put serious on that. You just know kalau if you have 1000 N, so 1000 monomer combine, so dia akan jadi polymer yang mengandungi 1000 monomer dalam tu. But it's only one polymer. So 1000 monomer jadi one polymer yang ada 1000 benda dalam tu. That is what is N. And N mesti ditulis di bahagian belakang dan bawah like this. So what is the name? The name is very simple, polyisoprene. Okay. So from this structure, this is kita kira yang simple punya polymer. If we try to show dalam bentuk polymer yang besar, what does it mean by repeating subunit. So from this, we turn into this structure. Okay, so where it's repeat, so the repeating happen 1, 2, 3, 4. This is one monomer. This is the second monomer. This is the third monomer. This is the fourth monomer. So we have 4 monomer for this diagram. They combine, they try to combine, so they connect each other. This is the connection between them. They connect, okay, and then they form a polymer of the rubber molecule, natural rubber. Okay, so we settle about the drawing structural formula for the monomer and polymer of rubber. So now look at to the rubber particle cross section. Okay, so as we know, when we touch the rubber tree, so apa yang kita akan nampak, we can see this white liquid come out from the rubber tree. Dia warna putih. Okay, so where is our polyisoprene? Mana sebenarnya polyisoprene? Okay, so for your information, actually latex is a colloid. What is colloid? Colloid is actually a mixture. Is a mixture of one substance of microscopically dispersed and suspended throughout another substance. What does it mean? Meaning that we have a very, very small substance. It's very small. So it is dispersed, berselerakkan and suspended. Dia terapung throughout another substance. What is the another substance? Another substance here is, for this situation, is the water. Okay. So what is come out from the rubber tree is actually kita ada satu benda yang mana benda tu disperse in water. So bila water to move, because it is very small, it's also going to move out from the rubber tree. So apa benda yang colloid tu, what is the thing? Okay, so to explain about this, let's look at to the cross section. Okay, so this is the rubber particles. What is rubber particles? When we are talking about rubber particles, it actually the rubber molecules. Rubber molecule, what is rubber molecule? This is our polyisoprene just now. The polymer itself. The rubber molecule, dia macam rambut macam tu. Okay, the rubber molecule, dia macam rambut. It is consists of carbon and hydrogen. So this is, as you know, carbon is non-metal, hydrogen is non-metal. So non-metal and non-metal, so they are not dissolved in water. Okay, so the idea is they are not dissolved in water, and they all is enclosed, dibaluti with the protein membrane. Okay, very thin protein membrane, and this protein membrane is negatively charged. So if I have 2 rubber particles, so I need to draw the rubber molecules, rambut-rambut ni, and then I need to draw the protein membrane with negatively charged, and don't forget about water. This is how I represent the water. Okay, so this is rubber particle. Rubber molecule, rambut. Rubber particle is rubber molecule enclosed, yang ditutupi dengan negatively charged of protein membrane in water. So if I have 2 rubber molecule, each of them is negative. I have 2 rubber particles. So dua-duanya ada negatively charged protein membrane. So when they duduk sebelah-sebelah, what happen? They all akan repel. They are very small in water. Okay, so itu menyebabkan dia digelar sebagai colloid. To make you understand about colloid, this is the difference about colloid and solution. Solution is like when we have table salt, garam, and we put in the water, we stir. What happen is like the salt is gone. It is not gone, actually is dissolved in water. Dia larut dan dia membentuk salt solution. Colloid, what is colloid? Like we have the milk powder, susu tepung, and then we put in the water, okay, and then we stir. Okay, if we look closely, we can see susu tu dia terapung dan berselerakkan di dalam air. That is colloid. And that is what happened to the rubber particles. Rubber particles is very, very small. Rubber particle tu apa? Rubber particle is rubber molecule that is yang tak dissolve in water sebab dia covalent, dia ada carbon and hydrogen. So rubber molecule enclosed by negatively charged protein membrane. So each of them very small and kita tak nampak dengan mata kasar because it's too small, and they cannot be big because whenever they try to keep close, nak dekat je dia akan repel. So when you touch the rubber tree, they all akan come out because they all ni berada di dalam water. That is the concept of colloid. Okay. So the product from rubber tree, there's a lot. We can make tires, we can make rubber band, okay, glove, and so on. Okay. So this one you can explore by your own. There's a lot of information you can surf from the internet. So what I want to talk about today is about the coagulation of latex. Coagulate. Okay, the concept of coagulate. So this is the cross section of my rubber particles. So I have 3 rubber particles. 1, 2, 3. Can I see them with my bare eyes? The answer is no, because they are too small. They are colloid because actually they are solid. They are solid in like solid in liquid. They are colloid. Okay, so kita tak nampak. Okay, so this is the all dalam rubber tree. So the negative, they have negatively charged. Okay, what the negatively charged did, they make the protein membrane to repel each other. So dia akan tolak-tolak. Okay. So when we add acid, the idea here is we add the acid into the latex, and normally we add the methanoic acid or any acid actually. Okay, you can have methanoic acid or formic acid or any acid you can add. Okay, it's added into latex. What we have in acid, so everyone knows acid contain hydrogen ion. What is the characteristic of hydrogen ion? It's contain H+. Okay, this is one situation we add acid ataupun cuka getah. Okay, or maybe we don't add acid, nak save budget, so we just let the latex expose overnight. Latex expose to the air overnight. So what we have in the air surrounding, for sure we're going to have the bacteria. So what bacteria will do, bacteria will enter the latex, and the bacteria itself will produce lactic acid. It also contain acid, it also contain hydrogen ions. So what this hydrogen ion did, the hydrogen ion for sure dia akan mencari dia akan menjalankan peranan dia. So just now kita ada negatively charged protein membrane. So hydrogen ion, what the hydrogen ion do? It will neutralize. So this is the term that you have to memorize, that you must use to explain about coagulation. The hydrogen ion neutralize. Don't forget this keyword is really important. Neutralize apa? Neutralize the negatively charged protein membrane. So positive jumpa negative. So what happened? So it's become neutral. Yes. Now the protein membrane become neutral. Do they collide when it's neutral? Yes, the answer is no more. Tak ada apa yang menghalang dia. Do they repel when they neutral? No, dia tak akan repel. Dia tak akan repel sebab dia boleh pergi dekat sebab dia dah neutral. So when they come close together, bila dia rapat, for sure the rubber particles will collide. Apa dia rubber particles? Rubber particles is the rubber molecule yang ada dalam protein membrane. Okay, so they're going to collide because the protein membrane is very thin and weak. So when they collide, the protein membrane will break, pecah. So what we have in our protein membrane, okay, don't forget in protein membrane we have rubber molecule, which is our polymer, which is our polyisoprene yang dalam bentuk rambut tu. So kalau satu particles of rubber we cannot see, let's say thousands of rubber particles collide, lepas tu dia break, lepas tu and then the rubber polymer, okay, or rubber molecules, when they break, they will combine and entangle. Okay, combine and entangle. Okay, entangle and combine with one another. That cause latex to coagulate. So dia bergumpal lah. So when this happen, we can see the rubber polymer easily. It's like kalau we have a very small semut lah berjalan, we cannot see. So what happen kalau you ada 1,000 semut bertindih-tindih and then bergerak ke arah you, so for sure you can see very easily. Okay. So when the latex coagulate, this is what you can collect daripada bekas yang letak dekat rubber tree. Dia dah jadi bergumpal macam tu, separate with the water. So you can see dalam cup tu water separate with the lump rubber bulat. The shape is like that because it's follow the shape of the container. The cup tu lah dia follow container cup dia tu biasanya bentuk macam tu. So that is the shape that you can get. The question here is, if we have the coagulated latex overnight, we left overnight and then it's turned to coagulated latex. Dia dah jadi coagulate. Can we turn back this coagulated latex into latex solution macam mula-mula dia keluar daripada rubber tree? Okay, so you need to answer this question and present to your teacher. Okay, this is an example of a rubber before it's processed to the product. Kita ada rubber sheet and block rubber. Okay, this rubber sheet and block rubber is processed from the latex solution. Okay, meaning that kita kena bawa daripada ladang latex in the form of solution. If we left overnight, kita tak buat we do nothing, we just left overnight, so for sure we don't have the latex solution. Apa yang kita akan dapat, we will get the latex that already coagulate. Tapi what we need is the latex in the form of solution, because certain product dia datang daripada latex solution. Dia tukar jadi sheet rubber dulu. Okay. So, how to make sure that latex do not coagulate even though we expose to the air overnight? Okay, mean that we have to do something. Okay, can we prevent bacteria from enter if we left overnight? For sure, the answer is no, because bacteria is everywhere. We cannot control the bacteria from enter to our latex. The bacteria will still enter to our latex, will still produce lactic acid. But how to prevent it from coagulate? Coagulation will not happen if we keep our latex always repel to each other. Our rubber particle always repel, meaning that kita kena pastikan dia always repel, protein membrane tak pecah. So how to make sure dia tak repel? Okay, we have to keep the negatively charged, right? So the negatively charged around the protein membrane, kita kena keep. Tapi when we left overnight, bacteria is there. Bacteria akan buat kerja dia. So macam mana nak prevent? So as we know, the bacteria is very slow action, sangat perlahan. So we can keep the negatively charged protein membrane still negative if we add on negatively ions. Tambah lagi negatif, let's say kalau ada 50 je, itu mampu untuk bakteria neutralize kan. So kita add on sampai 1000. So bacteria just neutralize 50. So the rest is still negative. That's the idea. So what else? What is the substance that we can add to make sure the rubber particles keep negative? Kalau nak coagulate, kita tambah acid. Kalau nak prevent coagulate, lawan kepada acid. So lawan kepada acid adalah alkali. So what we use, we can add ammonia solution. Make sure you write down the word solution here. Sebab kita bukan tambah gas, kita tambah ammonia in liquid form. So who is ammonia solution? Recall in previous topic, ammonia solution is a weak alkali. Actually you can use any alkali, even though strong alkali, tapi weak pun dah jadi, pakai weak je lah. Okay, weak alkali. And what is the most important thing is contain hydroxide ion. Apa yang ada pada hydroxide ion? Hydroxide ion contain negatively charged. So we add on more negative ions in the rubber particles. So hydroxide ion, what the hydroxide ion will do? Hydroxide ion will neutralize. Still the keyword is neutralize. Kali ni dia neutralize the hydrogen ion that is produced by the bacteria, because we cannot prevent the bacteria daripada masuk. So bacteria still akan masuk, still akan produce hydrogen ion. So this hydroxide ion yang akan neutralizekan the hydrogen ion from the bacteria. Because the bacteria action is very slow, so is when we add more negative ion, so what happen? The negatively charged of protein membrane will remain negative, sentiasa negative. So what happen? They will keep repel each other. So is there coagulation occur? The answer is no. So even though we left overnight, esoknya pun we can go and collect latex in the form of solution and we can process. Okay, that's all. So I'm going to continue in next video.